we will discuss on the topics mole concept and stoichiometry, and this will be the first video related with your physical chemistry, mole concept and stoichiometry, physical chemistry. Has one mole concept and stoichiometry. So today I will discuss upon the first part, mole concept, and the next part will be continued, and then finally I will come to the stoichiometry. Before understanding the mole concept and stoichiometry, first of all we will discuss about a.m.u. What is a.m.u? This is the abbreviated form of atomic mass unit. That is known as, in brief, a.m.u. Here, atomic mass unit means it is a type of unit for finding the mass of any atom of an element. And we know that atom is very small and it is spherical in shape, and the original weight of atom cannot be obtained in terms of gram or kilogram. It means there is need of the new unit so that we can easily write the answer of any weight of an atom or molecular weight. Therefore, new unit for the measurement of the mass for the tiny particles like elementary particles, electron, proton, neutron, atoms, nuclei, molecules, there is need of this new unit. Actual weight of an atom of C12 carbon isotope is 1.992647 into 10 raised to the power minus 26 kilogram, and this was obtained by mass spectrometer. Using mass spectrometer we can get the actual weight of an atom, and for the C12 carbon isotopes this is the actual weight. Now we can convert this in terms of gram, simply multiplying by 10 raised to the power 3, and solving we will get 1.992647 10 raised to the power minus 23 gram. Now we will take the 1/12th part of this actual weight of an atom C12 carbon isotopes. So here a.m.u means 1 mu, and this is always equal to 1/12 of actual weight of an atom of C12 carbon isotopes. So this answer is 112 multiplied by actual weight of an atom of C12 carbon isotopes. And we know that carbon has 3 isotopes, C12, C13, C14. So I am using here C12. And C14 is used in the case of carbon dating. So by putting the value of actual weight of C12 carbon isotopes, that is in gram 1.992647 multiplied by 10 raised to power minus 23 gram, and the same answer we can write 1.992647 divided by 12 into 10 raised to power minus 23 gram, and this is the smaller value, and for the bigger value the exponent of 10 is positive, and this is taught in mathematics in CBSE for the class 8 for the smaller number, and in the class 7 for the bigger number representation. That is called standard form of any number. That is written in the form x into 10 is raised to power I, where x must be lying between 1 and less than 10. So x is a rational number that may be 1, but excluding 10, always we have to write this number. And this I is the integers that may be positive integer or negative integer or 0 also. So in the class 7 in mathematics, for the whole number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, the symbols can be written for the standard form of any rational number. A standard form. This is called standard form of a rational number. Standard form of any rational number. And for the class 8, this integer will be negative integers. So using class 7 and 8, this is the concept. So in terms of standard form, we have to write this one. So how is it possible? We cannot divide here because this is 1.9 and this is 12. So simply multiplied by 10 in the numerator and denominator. So what will happen? Just you multiply 10 and divide 10 and bring these two at a time using the law of exponent, and bring this 10 here multiplying by this. So this converts 19.92647 and divided by 12, and these answers would be 10 raised to power minus 23, and this power is 1. So by using the law of index, this will be 10 raised to power minus 24. And by dividing this actual division, these answers converts into 1.66 into 10 raised to power minus 24. And this was in the gram, here also in the gram, this is also in the gram, this is also in the gram. So we can say 1 a.m.u or a.m.u, that is equal to 1.66 10 raised to power minus 24. No need to remember. How this answer comes, you have to understand by the using of arithmetic. Arithmetic is taught in the class nursery, LKG, UKG, in standard 1, 2, as well as in your 3, 4, 5. And finally this also used in the higher classes 6, 1, 8, 9, 10 or 11, 12. Or in the higher classes also in graduation level, BSc honors in mathematics honors, or in past course or subsidiary, or in MSc mathematics, and you are acquainted with the concept great persons mathematician Ramanujan. He had the great command in the number system, number theory, and this number theory is the your backbone to understand the nature or universe. So mathematics is the language of nature to understand, and here in physical chemistry there is great use of the arithmetics, and if you don't have the ability to solve, so no problem can be solved. Okay, and another concept is the formula of the chemistry must be you have understood clearly, as well as derivation of the formula. Don't think that derivation only comes in the mathematics and physics. In chemistry also all the formula you have to derive. So number one concept is the derivation, number two formula listing, and number three is the numerical calculation. And not only three, and the first one is your understanding of the question. If you understand the question in the great strength, in the great detail, then no any problem in this universe which cannot be solved in the physical chemistry. Okay, so these answers we can extend again. So here I am getting finally 1 a.m.u is equal to this. So I am writing here 1 a.m.u is equal to 1.66 10 raised to power minus 24 gram. But the same answers we can write in another way, that 1 divided by 1, again you write 1 by 1.66 10 is raised to power minus 24 gram. Now we will solve this one. So how it will be solved? Simply you write here 1 by 1.66 multiplied by 10 raised to power 24. Okay, and simply you multiply in the numerator and denominator by 10, and finally bring these two at a time so that these two converts in the form 10 raised to power 23, and this will be 10 divided by 1.66. So next step I am writing here. So this answer convert 10 divided by 1.66 multiplied by 10 raised to power 23, and this answer is in the gram. Now by actual division this answer will be 6.023 10 raised to power 23, and this is the great number which is associated with your Avogadro number. So this is your 1 by, this answer 1 by. So here also we will write here 1 by. So write here in the numerator 1, and here equality sign, and here also 1 by this one, and finally this great answer comes 1 by, this answer is Avogadro number n, 1 by n gram. So now we are getting another formula, that this 1 a.m.u, this was the 1 a.m.u, and here 1 a.m.u can also be told as equal to 1 by n gram. So 1 a.m.u is equal to 1 by n gram. No need to remember the formula, but if you understand the arithmetical calculation, then you can understand this is the second relation, and this was the first relation. 1 a.m.u is equal to 1.66 into 10 raised to power minus 24 gram. So we are having two formula, number one this equation and number two this equation. Now we can combine both. So finally I am writing here, that is 1 a.m.u is equal to number one, that is 1.66 10 to the power minus 24 gram, and another answer 1 by n gram. So this is the final answer for the a.m.u, and this a.m.u is, again you can say, this is equal to 1/12 original formula, 1/12 of actual weight of an atom of the C12 carbon isotopes. So I am writing here simply 1/12 multiplied by actual weight of C12 carbon isotopes. So this is all about your a.m.u. Enjoy with this little bit concept, and in the next video I will discuss about the atomic weight